Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is Victor. Today we're continuing our journey through concurrent design patterns in Java. Last time we discussed the producer-consumer pattern, and now we're moving on to the ReadWriteLock pattern. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to explore this powerful concurrency pattern with our listeners. Before we start, I'd like to remind everyone that understanding basic thread synchronization concepts will be helpful for today's topic.
Great point, Victor. Listeners, if you need a refresher on synchronization basics, check out our earlier episodes in the Fundamentals of Concurrency season. Now, let's kick things off with a quiz question. In a scenario where reads are much more frequent than writes, which would generally perform better? A standard synchronized block or a read-write-lock?
Ooh, that's an intriguing question, Sheila. It really makes you think about the trade-offs between different synchronization mechanisms. I'm sure our listeners will be pondering this as we go through the episode. Let's break it down step by step and see if we can give them enough information to figure it out.
Sounds good. So, Victor, can you start by explaining what exactly the read-write-lock pattern is?
Certainly. The ReadWriteLock pattern is a way to manage how different parts of a program access shared information. It allows multiple parts to read the shared data at the same time, but ensures only one part can change or write to the data at once. It's based on the idea that reading doesn't change anything, so multiple reads can happen together without causing problems.
That makes sense. So it's like a library where multiple people can read books at the same time, but only one person can check out or return a book at once.
That's an excellent analogy, Sheila. In our library scenario, readers are like parts of the program that want to read data, and the librarian checking out or returning books represents a part that wants to write or modify data. This pattern is particularly useful when you have information that's frequently read but not often changed.
I see. So how do we use this pattern in Java?
In Java, we use something called the ReadWriteLock interface. It's part of a package in Java that helps with managing concurrent operations. The most common version of this is called ReentrantReadWriteLock. It gives us two types of locks, one for reading and one for writing.
Could you explain how we might use this ReentrantReadWriteLock in a simple way?
Of course. Imagine we have a piece of data that we want to protect. We'd set up two types of locks, a read lock and a write lock. When a part of our program wants to read the data, it asks for the read lock. Multiple parts can have this lock at the same time, but when a part wants to change the data, it asks for the write lock. Only one part can have the write lock, and no one else can read or write while it's being held.
That's really interesting. But I'm curious, are there any potential pitfalls or common misunderstandings when using read-write locks?
Great question. One common pitfall is something called write starvation. If you have a lot of readers accessing the data all the time, writers might struggle to get their turn. Some versions of read-write locks, like the ReentrantReadWriteLock we mentioned, allow you to set up a fair system to make sure everyone gets a turn.
Oh, I see. So it's important to consider the balance between read and write operations in your specific use case. Are there any best practices you'd recommend?
Absolutely. Here are a few tips. 1. Use read-write locks when you have a situation where reading happens much more often than writing. 2. Keep the protected sections of your code as short as possible. 3. Always make sure to release the locks, even if something goes wrong in your code. 4. Consider using newer versions of read-write locks that came with more recent Java updates, as they might offer better performance.
Those are great tips, Victor. Now, I'm curious about how read-write locks compare to other ways of managing concurrent access that we've discussed before, like synchronized blocks or reentrant lock.
That's a crucial point of comparison, Sheila. Read-write locks can work better in situations where you're reading data much more often than you're changing it. This is because they allow multiple readers to access the information at the same time, whereas other methods might only allow one at a time, whether they're reading or writing.
Interesting. That brings us back to our quiz question. Based on what we've discussed, in a scenario where reads are much more frequent than writes, a read-write lock would generally perform better than a standard synchronized block. Is that correct?
That's exactly right, Sheila. In situations where reading happens a lot more than writing, read-write-locks can really improve how efficiently your program runs. However, it's worth noting that for simpler scenarios, or when there's not much competition for access, simpler methods might work just as well and be easier to use.
Thank you for that clarification, Victor. Before we wrap up, do you have any interesting facts about read-write-locks?
Actually, I do. Did you know that many database systems use a form of read-write locking internally? It's called multi-version concurrency control, or MVCC for short. It allows databases to handle lots of read and write operations efficiently, which is crucial for their performance.
That's fascinating. It really shows how widely applicable this pattern is. To summarize today's episode, 1. The read-write-lock pattern allows multiple readers but only one writer at a time. 2. In Java, we use the read-write-lock interface, commonly implemented by ReentrantReadWriteLock. 3. Read-write-locks can improve performance when reading happens much more often than writing. 4. It's important to be aware of potential write starvation and use appropriate fairness policies. 5. Always consider the specific needs of your application when choosing how to manage concurrent access. Next time, we'll be discussing the thread-safe singleton pattern. Don't forget to subscribe and rate our podcast if you're enjoying these deep dives into Java concurrency. Until next time, happy coding!